Hi, I'm Adam and welcome once again to South Wales Ghostwatch. Now on tonight's show, you might remember from last week, we mentioned quantum mechanics. Well, we're going to be discussing quantum physics, mechanics and psychology. Okay, now Martin, what is quantum physics a study of?
Well, wow, that's a biggie. We are trying to understand the basic nature of reality. Now, when Isaac Newton came along, he argued that the universe was a great machine in which everything was predictable and everything worked in particular ways. In 1912, Lord Rutherford said there was nothing left to find in science. There was nothing that was mysterious, and it would all be just final bits would be discovered in the next 10 years. There was a little guy called Albert Einstein, probably a slightly autistic, brilliant mind, working in a post office, who had a particular way of thinking about the world, and he decided that the general principle of relativity, and this was the idea that the world is not a machine. It appears to be a machine, but when we get to the subatomic level, it certainly isn't. That what it is a field of very tiny particles, so small that each particle was aware of the other particle. That each electron in the universe is aware and influenced by, and when I say aware, I say that's a bit difficult. I don't mean aware perhaps in the same sense that you or I are, but it's aware of where that is. So it isn't a machine, it's an energy that responds in particular ways. Einstein's theory had such tremendous effects, not only on science, but on the way we look at the world. It has implications for psychology in the fact that the world isn't rational, that it isn't predictable, it isn't a machine. It helps explain how things happen, we think, but we're still not sure. Einstein refused to deny the existence of a creator. He didn't ever use the word God, but he used the old Hebrew way of the old one. And he was always interested in how that fitted in. And so what seemed to be certain under Sir Isaac Newton, though I want to slightly qualify that a bit later, broke down entirely with Einstein and changed how we looked at certainty. Einstein says at certain times that an electron is both a wave and a particle. Now, how it can be both and behave in certain ways, in different ways, at different times, is unique. Heisenberg, who talked about the uncertainty principle, observed the behaviour of electrons. And he said that when you observed an electron, it sort of behaved in a way as if it knew that it was being observed. Now, I don't quite know what that means, but it's if the very act of observing something changes what you notice and the thing that is observed. Do you get what I mean?
Yeah.
So,
right.
The very fact of observing something changes how it is and how you perceive it.
So it's got its own energy, its own kinetic energy kind of thing, is it?
I suppose you could see it like that, but also that it behaves in a way. And there is an argument, as I said, if every electron knows where every other electron is, then that means that you and I are made of the same stuff.
Yeah.
And that there is no real separation, that there is just electrons that make up our bodies.
Yeah.
So that's where quantum physics begins to ask some really powerful questions about the nature of reality.
Okay, so what year does quantum physics date back to?
Now that's an interesting one. Sir Isaac Newton, who is the father of the mechanical universe, after doing a lot of conventional science looking at gravity and so on, for the last 20 years of his life talked about a subject that was very, very difficult for people to take seriously. He spent 20 years of his life researching alchemy, about how you could change base metal into gold. Now, lots of that stuff was hidden away because the scientists kept going back to Newton's papers and looking at what he said, and if they found it was a bit weird about alchemy, they said, oh, he's gone a bit mad. We just ignore that. So they only look for things that confirmed their view of the world. The truth is that we only look for evidence that confirms our view of the world. So half of Isaac Newton's stuff was locked away in the, I think it was Oxford, where it was left for 300 years. Now, in 1912, as I mentioned, that little semi-autistic guy called Albert Einstein began writing about quantum mechanics and quantum physics. And he postulated that you could change elements technically, from base matter into gold. We can do it now, but it doesn't last long. Yeah?
Yeah, yeah.
1936, the great economist J.M. Keynes, who had read Einstein, purchased the alchemical papers of Sir Isaac Newton. When he read them, he realised that Isaac Newton, probably 300 years before Einstein, was describing what Einstein had said, that we could do that. But nobody had the materials to understand that Einstein was not talking about flights of fantasy. He had actually thought out what Einstein had stumbled on or discovered. And if you go back to some of the ancient Hindu texts, they talk about creation in a similar way to the quantum physicists. So what is really interesting, that this idea that we can change, that we are evolving, I can think of at least 3 situations where it's been described. But the problem is, we're going to talk about a difficult word now, really difficult word, paradigm. Right. A guy called Thomas Kuhn in the 1960s argued that it was very difficult for people to see the world from another perspective, because we all grew up in a paradigm, a way of seeing, a way of looking. And that when those ways of looking changes, we cannot communicate with people effectively who believe in another paradigm, another way of looking at the world.
Right.
So, for example, it would be very difficult for Margaret Thatcher to experience the same paradigm shift and understand how Tony Benn would look at the world. Both use different techniques.
So what you're saying is if one person's got the belief in something and the other person believes in something else.
Well, it might not only be belief, it might be the tools of analysis.
Right. Yeah,
the way you look at things, the way you look at things. And what we do know is that those people looking at Isaac Newton's papers on alchemy before Einstein didn't have the scientific concepts, methods or approaches to analyse it properly.
Right.
So, as a result, it was nonsense to them.
Okay.
Yeah?
Yeah, yeah.
Now, paradigm shifts occur when there are so many anomalies in another, and it may simply be that science goes through revolutions where one approach breaks down and another approach comes in. Quantum mechanics, quantum physics, is such a paradigm. Yeah?
Right, right.
In which in which the world is interpreted in an entirely different way, that things are more random, that everything has effects on everything else. So quantum physics has implications not only in science, it has implications for spirituality, for religion, the nature of life, death, whatever. If everything that you and I were made of broke through and was made at the time of the Big Bang, and because of the conservation of energy, every part that made up you or I will still be there, and will always be there. Now, whether that means that in the end we'll be in another body, the particles that have made up you and I have already probably travelled back and forth to the sun 7 or 8 times since the creation of the universe. So the idea of survival after death is quite interesting from that sort of implication. The idea that you could create energy out of... nuclear energy was by splitting the atom.
Yeah.
And it may well be possible that we can split the proton and the neutron as well.
Oh, right.
Yeah.
Yeah.
So that we look at different paradigms at different times.
I see.
And quantum physics, therefore, can explain that there is no such thing as certainty, just possibility.
Okay. So what can you tell me about probability amplitudes? I understand they were developed by Max Born.
Yeah.
And were used to make physical predictions.
Yeah, that's right.
Yeah.
I mean, there is a problem here. If we know enough information, we can predict how things are going to be. I spend my time doing psychotherapy, and I see patterns repeating themselves over and over again. They're never quite the same pattern, yeah?
Yeah.
But there are certain patterns of behaviour that you spot. There are approaches that people take. People make the same mistake over and over again till they learn, and the probability changes and new possibilities occur.
I see.
Most breakthroughs in science are accidental. So, for example, let's bring it down a little bit. Viagra was discovered by accident. It was a treatment initially for Parkinson's. They noticed that it had other side effects when it was used. Penicillin grew accidentally in a petri dish. Yeah?
Wow.
Yeah?
Yeah.
All sorts of possibilities happen like that. And there is an idea, we've mentioned it before on this show, the idea of the black swan.
Yes.
The black swan is an idea that happens, that changes everything, but cannot be predicted. We can predict certain patterns and certain approaches, but if we are constantly feeding in all the time different solutions, different approaches, in the end the quantitative change becomes qualitative, that together something happens that was not predicted before. Yeah?
Yes, yeah.
So if we think about how evolution happened, it seems as if things build up to a certain point, and then there is a pressure, something else changes.
Yeah.
For a long period in history, it's called the Edikora Biota. There was a lovely warm planet where the sun shone, there were these beautiful oceans, and the creatures that lived in this ocean didn't have skeletons, they didn't have mouths, yeah? They absorbed through, like they absorbed plankton, yeah?
Yeah.
And for 50 million years, these creatures, we can't even really talk about them as creatures, I suppose, existed. And then suddenly, things developed with teeth. And that was the end of them.
Okay.
Yeah?
Yeah.
So there are critical moments. The first, we're still trying to work out how life began. The first example of life, for example, was a thing called Charnia. It behaved like a plant, but in many cases it was like, it was both plant and animal.
Okay, right.
And then, but suddenly something happened. We know, for example, we need water, we need carbon, we need oxygen, yeah?
Yeah.
And then something happens, an unintended consequence that makes it happen.
Yes.
Something else evolves from it. There was a creature, for example, after that had 360-degree vision. It could look through 360 degrees.
Wow.
Now we can't conceive of that.
No.
Because we don't.
It can't be predicted.
No, indeed. So it developed in that way. So probability gives us trends, but it never really makes certain what's going to happen.
No.
Yeah?
Yeah.
So, for example, we're pretty sure, but we can't know for sure, that we are probably the only species that can conceive of death. Yeah?
Yeah, yeah.
But it's because what we're able to do is observe, pass information on from one place to another, store our information, but we know of elephants, we've also seen examples of monkeys and elephants experiencing grief. And it's almost like the function of the mind becomes more and more complex, and then it adapts.
Yes, yeah.
So perhaps what we're actually doing is evolving gradually towards a point when we realise we're all the same. We're all one.
Yes, and you mentioned that we're all made up of electrons.
We're all made up of electrons.
Yeah.
Yeah. For example, if I say to you, if I ask the viewers now to stop thinking, just stop thinking.
Yeah.
You can do that for about 2 seconds, and then you start saying, I shall use a method to stop thinking. Then, of course, by saying that, you are thinking.
Yes.
Yeah?
Yeah.
If you use the word I am,
yeah,
that's difficult, because how do you know you are? Yeah?
yeah.
So it's very difficult to switch off the processes of our mind.
Right, yes,
Yeah?
of course I understand.
So it's all about perception. So quantum mechanics is something that Einstein perceived, but that asks the question, what do we need to perceive next? What will happen? So quantum mechanics says we're not a machine, we're more like an adaptation, a constant learning. We are a process.
Right.
There is a rather interesting book called I Am a Strange Loop, which talks about us being circular. We go round and round and round thinking, I am.
Yeah.
And
Okay.
it might be the degree to which we are. And that's perhaps what quantum physics, quantum mechanics most enables us to do.
Okay, we're going to touch on atomic theory now. This was Einstein's theory again. Physicists discovered the invisible atom,
Yes.
which can be broken down into electrons,
Yes.
protons and neutrons. Am I right in thinking that, yeah?
Well, some very ancient Greek philosophers, the pre-Socratics, Heraclitus, speculated this as well.
Yes, yeah.
He said there were minute particles, yeah, and it used to be thought that the atom could not be split.
Okay,
Okay.
yeah.
We now think we might be able to split protons and neutrons, and there are things called quarks now, and we've just gone through a thing looking for the Higgs boson particle. Yeah.
Right, yeah.
Because we still can't explain why protons and neutrons cling together. We say, well, they're electrical. It's electrical charge. But we're creating an idea.
Yeah.
And there was a time in history when we thought electrical charge and electrical charge and magnetic charge were different things. Yeah?
Yeah.
Now we know they're one. Yeah? And if we think of the structure of an atom, suppose we think of the Liberty Stadium or the Knoll. Yeah?
Yeah.
The thing on the proton and the neutron that's the nucleus of the atom is right at the centre of the pitch. Yeah?
Yeah.
The thing that's the electron is going around the outside of the pitch where the spectators are. There is effectively nothing between. So that means this desk, there are large spaces of emptiness in there.
Yes. Right. Okay.
Now, I can't break through that, as far as I know,
No.
because it's a perception. So quantum mechanics and quantum physics is saying, what is really there? Yeah? Now, if it is energy, then, as I said before, the bits of energy that begin from the beginning of the universe and will be there forever. The bits that are you and I will always be there. And if Heisenberg said the electrons behaved as if they knew they were being observed, how do we know that we are not tiny particles in a greater being?
Yeah.
And that we are made up of there are thousands of germs. I think in the Matrix, the robots observe that the only thing that the humans behave like are like a bacteria.
Yeah.
Perhaps there is something in that. And it all comes down to perception.
Yeah.
Yeah? So quantum physics makes us ask really serious questions about the nature of reality. And that's what is both scary and also very liberating about it.
Okay.
William Blake said, energy is eternal delight. Perhaps we will always be. Who knows? Quantum physics tells us a lot about the nature of life. And before Einstein, we saw space and time as separate things.
Yes.
But Einstein has discovered that space and time is a projection, is a continuation. So that when you ask the question, why are we here? Outside of space and time, there is no space and time. So you can't meaningfully ask that question.
No.
Because space and time are the same thing. So on the edges of the universe, it's not that there is nothing, no thing, because for there to be something, there has to be space and time. So if the universe is expanding outwards, we can't conceive of what is out there.
Right, yeah.
Because we now know that space and time is curved. And it's very difficult to get your head around that.
It is. I'm baffled.
and the nature of reality is very difficult.
Okay.
So, there are questions, perhaps, that we will never know the answer to.
Okay. Now I understand that Isaac Newton developed the corpuscular theory of light, where light particles have kinetic energy and can move in a straight line. Is that in reference to electrons, or is that something else?
What he's doing is, we know that light developed, we know that the human eye developed because of a response to light. We think that might be what actually helped our eyes evolve. Yeah. There are creatures that can see ultraviolet light. Yeah?
Yeah.
There are creatures that never develop sight because they live in darkness. Yeah, they don't need it. They have a massive sense of smell or taste. The catfish actually perceives chemicals.
Okay.
Yeah. Newton tried to work out what light was. For example, he stared at the sun and managed to burn the retina of his eye. Really? He did all sorts of interesting things like that.
How long did he stare at the sun?
I'm not sure. There was a program about it just recently, and he examined these things and worked out what was was going on. He worked out that light could be split. Yeah.
Okay. Yeah.
Into the prism. Yeah. But either side there is ultraviolet and so on. There are things we don't see because it wasn't necessary for us to see it, for us to develop.
Okay.
So Newton was working on perception, and that is what is so fascinating about it. What we don't need, we don't notice. And as we evolve, as we change, we'll probably develop new things. There is some evidence today that that younger people are far more talented with the internet and IT, because they have grown up with it longer.
Yes, and that's what
Yeah.
I used to. Yeah.
I mean, I didn't start using computers till I was about 25, which is 30 years ago, and the computers were very different. My son, he just knows what to do.
Yeah.
So we continually adapt.
Yes, of course.
Yeah.
Yeah.
So it might be that when scientists explore things, they explore things in terms of what they know at the time, but they're just indicators of what's possible.
Okay. Let's just find the next section now.
I mean, the whole thing about quantum physics is that it allows change to occur in the way we look at the world. It allows evidence to change. It allows us to think of different paradigms of ways of looking at the world. This paradigm shift approach is extremely useful.
Yeah. Yeah, you mentioned that earlier. Yeah.
But to be able to take a paradigm shift, you have to be flexible, you have to be able to take chances and move forward. And it may be that breakthroughs in science do not occur by steady progress, but by a whole series of revolutions, where one way changes from the other. Before Newton, there was a belief that the planets moved in all strange circles, went back on themselves, and whatever. When Newton came along, they could develop mathematics that predicted how the planets would work. And now we have Einsteinian theories which explain in different ways.
Okay. So is there a link between quantum physics and psychosomatic medicine?
What we think we are,
Yeah.
yeah, what we perceive we may become, yeah. If you think there's something wrong with you, you may actually influence your body to begin to behave in that sort of way. If you believe that you're never going to succeed at anything, you don't allow your mind, you don't allow the networks in your brain to think of yourself working positively and successfully. So it might be that it's not psychosomatic, it might be that we charge the electrons, they're all part of the field,
Yeah.
and that the field is effectively a store of information that we're still learning how to put things in, to input data and take out data. And what we might be doing when we have psychological crises is to respond. I'm going to give you a rather base description of how the mind affects the body. A guy sees a pretty woman, he might get an erection. Yeah.
Yeah.
Something in there has affected another part of the body. Yeah. It might be that the response to a certain thing, there's something happening in the mind that affects something in the body.
Yes, of course. Yeah.
And of course, I regularly treat gentlemen who have this problem, thinking, oh no, it's going to happen again, it's not going to work. And so they condemn themselves to do that way. I mean, I'm rather light-heartedly using sex because the viewers will always remember stories illustrating quantum physics by using a model of sex, because it's more interesting, really.
It's a good example, isn't
That's
it?
a good example.
Yes. I mean, from my research, I understand that Carl Jung believed that there were parallels between quantum physics and synchronicity,
Yeah, that's right.
and referred to it as unus mundus,
Yeah, that's right.
which is Latin for one word.
One world. And what it means is that if everything is electron, if every electron knows where everything else is, the psychological events within somebody affects the psychological events everywhere. And so, if it's field theory, if it's an information that's stored in a particular way, synchronicity occurs because the world, the electrons, are aware of what's going on everywhere else.
And we covered this on a previous show, didn't we?
And so synchronicity occurs because of that.
Okay. So what are the main concepts of psychology?
Understand the theory of how you are, what you are, what you will be, where you have come from. Develop tools of analysis and understanding, and that's very much a model of quantum physics.
Yeah, it is, because they do marry each other, don't they?
That's right.
Yeah, definitely.
Yeah.
So how can psychological traits be explained? For example, memory, perception, language, things like that.
Well, language, perception, memory is a grouping of data together that has an effect in a particular situation. Mm-hmm. There is an argument with language that the word cup, beaker, that beaker is separate from the idea of cup, but we've linked that together and we use it in that way.
Yeah.
A table is something to put something on. A chair is something we sit on,
Yeah.
but we can sit on a log,
Yeah.
or we can sit on a wall. So the difficulty of determining what is what and what is one thing and what is another. So we place order on the world.
Yeah,
It's not the world that places orders on us. Therefore, as we are, as we perceive, so we can be.
Okay, okay. So how do chemical reactions in the brain work when we feel certain emotions?
Well, there is an idea that a chemical reaction makes us think in certain ways, and that it's all the same. Now, we have different ways of thinking, yeah?
Yeah.
You have your mind, I have my mind, yeah? We might be able to feel love, hate, anger. If I see a picture of Margaret Thatcher, I loathe the woman. And as a result...
Some people beg to differ.
Some people differ. So that's the point, yeah? That's why I did that.
Yeah, of course, yeah.
Because I was trying to illustrate that there are different responses using the same mind.
Yeah.
So a chemical response might explain different reactions to Margaret Thatcher, yeah, but it doesn't say why. We have different tastes. You might find particular types of women attractive, I find another type of woman attractive.
Of course, yeah.
But we might find different types attractive. So it doesn't explain why you or I find different sorts of people attractive. It doesn't explain why certain things fascinate me more than fascinate you.
Yes.
We can say what goes on, yeah, but we can't explain it. Yeah. So we are beginning to reach that stage. There are some early some experiments recently where neurologists are beginning to be able to project from the mind an image that the mind thinks of. There was one where a car, was projected, onto a screen. But of course, you think of a car, I think of a car,
Yeah.
When I think of the word car, we both know what a car is,
Yeah.
But I think of the first car I was in, a Hillman Minx, I think about a Rolls Royce or something like that. But you say car, I say car. It's a different thing to each of us.
Yes.
Yet we can describe it.
Yeah, I mean, I've got an image in my head of a car now
Precisely.
I'm thinking of that I'll probably never have.
Precisely.
I'll not afford to buy,
precisely.
Yeah.
But the word is different.
Yeah, of course, yeah.
Yeah.
Okay. So how is human behaviour affected by the paranormal in relation to...
If you think about the electrons affecting every other electron, it may simply be that a paranormal or psychic ability is an ability to look into the field and change it. So that what psychics and mediums do is just have an ability of greater awareness that other people don't have.
Okay.
And therefore, if they've got it, we can all learn it.
I see. Okay.
Okay.
Well, thanks very much for
Thank you.
coming on the show again, Martin. It's been a pleasure talking to you as always.
Thank you.
And that's all we've got time for tonight, guys. But tune in next week where we're going to be discussing science, spirituality and health. Okay, and it does kind of link in with what we've discussed this evening. So that's it from me. Take care. Have a good evening.